Hello students, today's topic is 10th geometry, chapter number 1, similarity. This is lecture number 6. In previous lecture we studied the theorems, basic proportionality theorem, angle bisector theorem and property of three parallel lines and their transversals. So before starting practice set 1.2, here we have to revise these theorems first. So see here, basic proportionality theorem. So here is triangle ABC, and in that triangle this segment PQ is parallel to segment AC. Then according to basic proportionality theorem, here we have this formula AP upon BP is equal to QC upon BQ, or we can write same formula in this direction. So BP upon AP is equal to BQ upon QC. You can change direction but formula remains same. So this is according to basic proportionality theorem, when one segment is parallel to the one side of triangle. And converse of this theorem, so when ratio is given, then we can say that line or that segment is parallel to the side of triangle. Here converse of BPT, ratio is given, so from this ratio we can say this segment EST is parallel to segment QR. Okay, so this is converse of basic proportionality theorem. Then second theorem was angle bisector theorem, or theorem of bisector of an angle. So according to this theorem, so if there is angle bisector, suppose in this diagram in triangle ABC, ray BD is the angle bisector. So if angle bisector is present in the triangle, then we have the ratio AB upon BC, that is this side, AB upon BC is equal to AD upon DC, or we can write in opposite direction. Here we can write AD upon DC first and then is equal to AB upon BC. This is theorem of bisector of an angle. And then third theorem was property of three parallel lines and their transversal. So if there are three parallel lines and there are two transversals, then the segments formed by each transversal are, their ratio is equal. So in this diagram, three parallel lines are AX, BY and CZ, and line L and line M are the transversals. Then according to this theorem, this AB upon BC is equal to XY upon YZ, or we can write here in opposite direction also, here CB upon BA is equal to ZY upon YX. So these are three theorems, important theorems in this chapter. And next practice set 1.2 is based on these three theorems. So we should know these formulas of this theorem as well as their converse also. Converse of this theorem, if a ratio is given, then we can say these lines are parallel lines. If line is parallel, then we can write a ratio. In angle bisector, if angle bisector is given, then we can write a ratio, and if we are given with ratio, then we can say this is angle bisector of that angle. In three parallel lines and their transversal, their segment ratio of segments are equal. So we have to remember these formulas of these three theorems, and based on this the next practice set is there 1.2. So now we are going to start practice set 1.2. So this is practice set 1.2. See the question number 1. Given below are some triangles and lengths of line segment. Identify in which figure ray PM is bisector of angle QPR. So three diagrams are given. In each diagram, here a triangle is there, triangle PQR, and in this triangle we have some lengths of line segments are given, and we have to identify in which figure ray PM is the bisector of angle QPR. Now this question is based on the converse of angle bisector, not depend on the angle bisector theorem. It is depend on converse of angle bisector. Now we have to find first ratio, and if ratio is equal, then according to converse of angle bisector, this ray PM become the angle bisector of angle QPR. So here we have to find ratio. If ratio is congruent or equal, then ray PM is the angle bisector. If ratio is not equal, then ray PM is not angle bisector. So here in first diagram or first question, see the ratio now PQ upon PR. So this side PQ upon PR, and this should be equal to, here if we take PQ first, then this side first QM upon EMR. So take PQ divided by PR. So PQ upon PR is equal to, PQ is 7, PR is 3. So PQ upon PR is 7 by 3. Now take QM upon REM. So QM is 3.5, REM is 1.5. Simplify this one. So 3.5 divided by 1.5. So shift decimal point of both to the right side, one digit to the right side. So 35 divided by 15, and if we divide this, if we simplify this by 5, then 5 3s are 15 and 5 7s are 35. So ratio become 7 upon 3, and here we can see both ratios are equal. PQ upon PR is 7 by 3 and QM upon REM is also 7 by 3. So we can say therefore PQ upon PR is equal to QM upon REM, and if ratio is congruent, then we can say this ray PM is angle bisector of that angle QPR according to converse of angle bisector theorem. So therefore ray PM is the bisector of angle QPR, and it is reason is converse of angle bisector theorem. Okay, then see the second diagram. Now in second diagram we have to take again ratio, that is this PR and here PQ. So take ratio as PR divided by PQ. So PR is 7 divided by PQ is 10. So this is equation number 1, PR divided by PQ. Now if we take first PR, then take REM first. So next ratio will be REM divided by QM. So REM divided by QM. So REM is 6 and QM is 8. Now simplify this one. We can simplify by dividing by 2. So 2 3s are 6 and 2 4s are 8. So this equation number second is 3 upon 4, and equation 1 is 7 upon 10. So these two ratios are not equal. So here we can write PQ upon PR not equal to REM upon QM, and therefore we can say in this second diagram ray PM is not angle bisector of angle QPR. Okay, because ratio is not equal. Then in third diagram, So take ratio again. So PR and PQ. So we can write here PR divided by PQ. So this is equal to PR is 10 divided by PQ is 9. So 10 divided by 9 is first ratio. Then second, if we take PR first, then we have to take REM first here. So REM divided by QM. So REM is 4 and divided by QM is 3.6. Now simplify this one. In 4, that 4 is nothing but 4.0. So shift one decimal point to right side, one decimal point. So this become 40 divided by 36. Now simplify this one by dividing 4. So if we divide by 4, 4 ones are 4, 4 0, 10 and 4 nines are 36. So this become 10 upon 9. So this is our equation 1. Now this is equation 2. So both equations are equal, 10 upon 9, 10 upon 9. So we can write here this PR upon PQ is equal to REM upon QM. And if ratio is congruent, then we can say therefore REM is bisector of angle QPR and reason is converse of angle bisector theorem. Okay, so thus we solve this question number 1. So in question number 1, this first diagram PM is bisector of angle QPR, and in third diagram PM is angle bisector of angle QPR, but in second it is not angle bisector because this ratio is not equal. Okay, so this is question number 1. Then question number 2. So in triangle PQR, this triangle PQR, PM is given. So see, PM is 15. Then PQ is given, that total PQ, this total distance PQ, this is 25. PR is 20, this total PR 20, and NR is 8. State whether line NM, this line NM is parallel to side RQ and give reason. Okay, now this is based on the basic proportionality theorem. Now here we have to prove that line, or we have to find whether line NM is parallel to side RQ. So this is converse of basic proportionality theorem, because in basic proportionality theorem initially we are given with line is parallel to the side of triangle. Okay, but here it is not given, we have to find whether it is parallel or not. So it is based on the converse of basic proportionality theorem. So here we have to find a ratio, and if ratio is equal, then we can say this line is parallel to side RQ. But here we are not given that segments, so we are given with PQ, total distance PQ, and PM, but MQ is not given. So we have to find this MQ first, and in second side here PR is given, NR is given, but PN is not given, so we have to find PN. Okay, so let's find it first. So this PN plus NR is equal to PR. So this PN plus NR, this total is equal to PR. So put values, PN is not given, NR is 8 and is equal to PR, total PR is 20. So PN is equal to 20 minus 8, so PN become 12. So this distance PN is equal to 12 and NR is given, NR is 8. Now similarly find this side. So PM plus this MQ is equal to total PQ. So PM is given, PM is 15. Now MQ is not given, so plus MQ is equal to total is 25. So MQ is equal to 25 minus 15, that is 10. So this MQ is 10. Now we have all segments. Now we can find a ratio. So find first ratio, this Pn upon Nr. So Pn upon Nr is equal to, Pn is 12 upon 8. Simplify this, so this become 3 upon 2. Pn upon Nr. Then this is our equation 1. Then find Pm upon Pq. So Pm upon Pq is 15 upon 10, and if we simplify this, divide by 5, then 5 3s are 15, 5 2s are 10. So this become 3 upon 2. This is equation number 2. So from this equation 1 and 2, we can say Pn upon Nr is equal to Pm upon Mq. So from 1 and 2, we have Pn upon Nr is equal to Pm upon Mq. And if a ratio is equal, then we can say this line is parallel to this line of triangle. So in next line we can write, therefore line NM is or parallel to side RQ. So this is our answer, and reason is converse of basic proportionality theorem. Okay, so this is answer of question number 2. Then question number 3. So in triangle MNP, so this total triangle NMP, NQ is bisector of angle N. Now here angle bisector is given, NQ of angle N. If MN is 5, PN is 7, MQ is 2.5, then find QP. So we have to find this segment QP. Now simple question this one, based on the angle bisector theorem. NQ is angle bisector of angle N, so it is given NQ is bisector of angle N, it is given in the question. Then if it is angle bisector, then according to angle bisector theorem, we have the ratio. We can write ratio, this Pn upon Mn is equal to, if we take Pn first, then to the right side we have to take this side first, PQ, or we can say QP. So QP upon MQ. So Pn upon Mn is equal to QP upon MQ, and what is reason? Property of angle bisector of triangle. Now put the values. Pn is 7, Mn is 5, QP we have to find, and divided by MQ is 2.5. Then this 2.5 become multiplied to this side. So this, now this become here 2.5's, if we divide by 5 to 2.5, 2.5 2's are 5, so we get 7 divided by 2, and 7 divided by 2 is 3.5. So QP we get 3.5 units. Okay, so this is answer of this question number 3. So all questions in this practice set based on these 3 theorems: basic proportionality theorem, angle bisector theorem, and property of 3 parallel lines and their transversal, and converse of these 3 theorems. Okay, so remember that 3 theorems and their converse, so we can easily solve this type of questions. So this is for today. Next remaining questions will be in the next lecture.